Today we will begin section 3.4, and what this is on is the final method of solving quadratics. We've already looked at solving by graphing, taking square roots, factoring, and completing the square. Next, we're going to learn how to solve by using the quadratic formula. You can always use the quadratic formula whenever needed. First, turn to page 62 of your journal and copy the definitions. Next, look at the core concepts for the quadratic formula. First, notice the formula given. You must memorize this formula here. To help you memorize this formula, you might want to say it in the tune of Pop Goes the Weasel. Here's an example.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
You may want to repeat the song until you have it memorized. Now, to use the formula, you're going to follow 3 easy steps. Step 1, you want to make the quadratic equation equal to 0. Then you can easily pick out and list A, B, and C. Once you've listed A, B, and C, you can carefully plug them into the formula. Once you plug into the formula, you just need to simplify. It's the simplifying that you have to be very careful with. Here might be a little tip when you go to simplify. When you first simplify, do the outside of the radicals. Then you can do under the radical. Then actually simplify the radical if needed. And then if you need to simplify the whole entire answer, do so. While we're in the journal, let's turn to page 63 and look at the next part of the core concept. This is analyzing the discriminant. The discriminant, notice, is simply b squared minus 4ac. If you recognize this, this is the part underneath the radical when we did the quadratic formula. So if under the radical is greater than 0, that means it's positive, and that means we're going to have 2 real solutions. So the quadratic will pass through the x-axis 2 times. If the part under the radical equals 0, that means the radical disappears and the plus minus disappear. That means we have 1 real solution, and notice the parabola will only touch and turn at 1 point on the x-axis. Lastly, if it's less than 0, that means underneath the radical is negative. That means we're going to get I in our answer, and we'd have 2 imaginary solutions. That means the parabola does not cross the x-axis at all. Now let's move to our notes pack. So in example 1, we're going to solve using the quadratic formula. Step 1, like we wrote in the journal, was to equal it to 0. So to do that, I'm going to subtract 5 to the other side. Looking at this, our first attempt would be to factor it, but there are no factors of 5 that add or subtract to 3. Therefore, we have to do something else. You could do completing the square, but dealing with 3 being odd makes it a little bit tricky. So let's do the quadratic formula. As a reminder, we might want to write the formula at the top of our notes. Negative b plus or minus square root b squared minus 4ac all over 2a. So let's list a, b, and c. A in this problem is 1, b is 3, c is negative 5. Carefully plug in each of the numbers. Notice I plugged everything in here. Now let's start simplifying. So let's simplify the outer. The negative 3, and underneath the radical, 2 times 1 is 2. Next, let's simplify under the radical. 3 squared is 9. 4 times 1 times 5 is 20. And then look at the signs. I have 2 negatives. 2 negatives turns into a positive. So under the radical, I have 9 plus 20, which is 29. Next, try and simplify the radical if possible, if you can take any perfect squares out. In this particular example, we cannot. So we're going to leave it the square root of 29. All over 2. So we are finished simplifying this radical. This is our final answer. Now for big ideas, you may have to plug in your answer separately. So write negative 3 plus radical 29 all over 2, and then your other solution will be negative 3 minus radical 29 all over 2. You can then enter each of those answers into a calculator to get the decimal forms if needed. Let's move to example 2. In example 2, if you read the title, we're going to be getting 1 real solution. So let's see what that looks like. Again, step 1, we're going to equal it to 0. So I'm going to move everything over to the x squared side. After doing that, I can easily pick out a, b, and c. A is 25, b is negative 20, and c is 4. Then carefully plug those numbers in to the quadratic formula. So we have negative b, which is negative 20, plus or minus square root b squared. Notice I always use parentheses when plugging in. Minus 4 parentheses a times c. All of this over 2a. So what I suggest is simplify the outside things first. So negative b ends up being positive 20. The denominator ends up being 50. Plus minus, now let's do the square root. Negative 20 squared ends up being 400. 4 times 25 is 100, and then 100 times 4 is 400 as well. Look, checking the signs, I only have one negative, so it's going to stay minus. So 400 minus 400 is 0. The square root of 0 can just drop. So I have 20 over 50, which reduces to 2/5. So I only have one solution here, 2/5. Let's look at example 3. If you read the title, this example is going to be an example where we see imaginary solutions. So again, step 1 will be set equal to 0. Once we do that, we can see that a will be negative 1, b will be 4, c will be negative 13. Carefully plug into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. My suggestion, reduce the outside number, negative 4, and the denominator will be negative 2. Now let's focus under the radical. 4 squared will be 16. 4 times 1 times 13 will be 52. Counting the negatives, I have 3 negatives, which is odd, so that means it'll stay negative. So now I can compute 16 minus 52 and get negative 36. Your next step would be to simplify the radical itself. It's negative, so I know I can definitely take an I out. And it's a perfect square, so it actually becomes plus or minus 6i all over negative 2. If you have all integer answers or no more radicals, you can continue simplifying some more. You can split up and make each of the numerators separately divided by the denominator. So you can say I put negative 2 under each. Then I can reduce negative 4 over negative 2 is 2, and then 6 divided by negative 2 will be 3i, and I know the signs will flip, but it's still going to be a plus minus. So there are your 2 solutions. So in the first 3 examples, in example 1, underneath the radical, we had an answer of 29, and then that gave us 2 real solutions. In example 2, under the radical was 0. That gave us 1 real solution. In example 3, under the radical was negative 36, and that gave us 2 imaginary solutions. So what we're going to be doing is analyzing the discriminant, and that tells us what type of solutions we have. You only need to do the part under the radical, which is b squared minus 4 times a times c, and then decide what kind of solutions you will get. So in part A, b is negative 6 squared minus 4 times a times c. Compute this in the calculator. We'll get 36 minus 40, which is negative 4. So because it's negative, or less than 0, that means we're going to get 2 imaginary solutions. Let's look at b. Not much is changing here. b squared minus 4 times 1 times c is 9 this time. So I'm going to get 36 minus 36. That gives us 0. That means the radical will drop out and we'll only be left with 1 real solution. In part 3, b squared minus 4 times a times c, what will our answer be, or our discriminant? We're going to get 36 minus 32, which is 4, 4 is positive, which means we're going to have 2 real solutions. Have your questions ready now.